Stay safe, happy learning. You can see the core and winding of a transformer. The inner yellow portion is LV winding, upper and this portion is HV winding. Transformers are vital equipment for power generating plant, transmission system and distribution system. The life expectancy of transformer is 25 years. However, the transformers fail premature and failure rate of distribution transformer globally is as much as 9% and that of power transformer is 1.5 to 2%. The failure of transformers could be attributed to electrical as well as mechanical reason. In this video, we shall discuss on mechanical reason of the failures. The mechanical reasons may be due to radial forces, axial forces, radial forces and unbalanced axial force due to asymmetry. Parallel conductors will repel or attract each other according to whether the current they carry are in the opposite or in same direction. Forces exist in ordinary stationary transformers, the cause being the interaction of currents in the winding with the leakage field surrounding the core. This is the core, this is LV winding, this is HV winding. Here are leakage fluxes. They have two components, axial component and radial components. The magnitude of force on conductor is proportional to the product of current in it and the intensity of magnetic field due to neighboring currents. And since intensity of magnetic field itself is proportional to the current, the forces are proportional to the square of the current. The forces with normal load currents are low compared with the strength of the windings and are not noticeable. But when large transformers are subjected to short circuit conditions at full voltage, the short circuit currents may reach 10 to 25 times of full load value with forces 100 to 625 times of the normal value. Under such conditions, the mechanical forces become so great that it is possible to wreck the transformer, and unless the coils are solidly pressed, they are bound to fail. Let us discuss first radial force. This figure shows core type transformer. This is core and these are windings. The radial components of the leakage, the radial components of the flux interact with leakage field and resolve into two components, radial and axial, as shown in this figure. The currents carried by windings interacting with axial component of leakage flux produce radial forces. The nature of these radial forces is such that they try to burst the outer. This radial force will try to burst the outer layer of the coil. So you might have watched oftenly that LT rarely fails, mostly ST side of the transformer fails. This is one of the reasons why ST side of the transformer fails. This is obvious because the two windings carry currents in opposite direction and hence produce repulsive force tending to pull the outer winding and to compress the inner winding of the transformer. It is clear that circular coils should be preferred. Isn't it? Circular coils should be preferred as they are the strongest to withstand these forces. Because the tendency of the radial force is to make the coils circular, and as they are already circular, there is no deformation. But if rectangular or square coils are used, they would be deformed by the radial forces. In cell-type transformers, here is a cell-type transformer. In cell-type transformers, the coils are rectangular. See the rectangular coils? But these coils are mechanically sound as sizable portion of the coil is braced by the core for considerable length. Next is radial forces. The winding currents interacting with radial component of leakage flux. The winding current linking with radial component of the leakage flux produces axial compressive forces tending to squeeze the winding together at the middle. At the middle, these axial force will try to squeeze each other. With symmetrical windings, these forces are not noticeable even at short circuit. However, the forces due to asymmetry is very vital. The ideal symmetry, which means windings of same lengths symmetrically placed with respect to each other, can never be obtained in practice because the transformers are provided with taps which include as well as exclude a part of the winding during service. This asymmetry results in axial displacement of windings. The results obtained above hold good for the total force, but this force will have both radial and axial components as shown in this figure. The radial component is FAV cos alpha and radial component will be FAV sin alpha and axial component will be FAV cos alpha. The radial component may easily take a value such that there is failure in transformer unless necessary bracings are done to prevent motion of coil along axial direction. In this figure shows two cylindrical concentric coils, one coil being shorter than the other. See here, this coil is shorter than this coil because of tap changers. The outer balance MMF is produces a radial field which in turn interacts with current in winding producing axial force. This axial force may develop to a quantity sufficient to lead the transformer to failure. Inward axial forces are taken by winding themselves. Inward radial forces are passed on to the formers, packing pieces and cores. Outward axial forces must be withstood by the end insulation. A well-constructed transformer should have suitable choice of conductor dimensions and inter-turn insulation, and the coils well supported and braced with compressive stress kept in view. The end supports are not easily arranged to give good insulation and at the same time good mechanical strength. So we will have to compromise somewhere. Therefore, the need for second quality, that is good mechanical strength, should be avoided as far as possible by having good magnetic symmetry and unpreventive asymmetry caused by provision of tapping should be suitably distributed. That's why at many places tap changers are removed from transformers. That's all. One more thing. This is the core of the transformer. If appropriately designed bracing are not placed on this, suppose a 100 mm thick bracing is required. Instead of 100 millimeter thick, 2 number 50 mm thick bracings are applied. In all probability, the transformer will fail under short circuit condition due to stress along axial direction. So that's all in this video. Please like, subscribe, comment. Thank you. Stay safe. Happy learning. Please check your subscription so that you don't miss next video from this channel. Thank you. Thank you very much.